We recently had the privilege to host Mikron Tools Medical Days here at the CME in Whitestown, Indiana. And I had a blast making these 3 medical parts. So what we want to do is talk about the 3 parts we made, how we made them, why we did what we did, and what you can do in the future to maybe improve your process or these processes using our partner technology. So we're going to start by talking about the femoral knee implant. This knee implant was made from a casted cobalt chromoly material. And what's really interesting about this material is that it's very hard and it's very abrasive. So you can have the best cutting tools in the world, but what really matters is kind of the synergy between your machine, your coolant, your tooling, your machining strategies. And if any of those fail or aren't doing what they're supposed to be doing, you're gonna have a bad time. So I kind of want to share the process, the tooling we used, and explain some of the challenges that we found, and then some ideas that we had after we finished this of what we could have done better and maybe what you could implement in the future. So first, I want to talk about the fixturing that we use. We're using Lang's 0-point plate and their 0.52 millimeter studs on this custom fixture to locate our fixture to hold the knee. The fixture itself was designed for a completely different machine, and so we repurposed it for this demo. Something to notice that's kind of different in some cases is that we're holding the knee at 90 degrees. This completely changed the strategy and the length of some of the tool holders that we used for this process. So as we look at the fixturing, I kind of want to show you what all we're cutting on the part, why we're doing it, and then we're going to take a step back and look at the tooling specifically. So if we look at the part, you'll notice that this fixture is holding everything at 90 degrees, like I said. And that means that a lot of this condyle servicing that you see here on the outside is being done using the C-axis. So as you look at your machine, you want to make sure that the axis that's jumping back and forth and doing these condyle services is rigid and accurate in that specific axis. In this case, the C-axis provides all the work we need. We lock the V in, we do a 4+1 strategy to stay rigid, because while simultaneous 5-axis looks really cool, it's not the most accurate thing in the world. You've got too many variables at play and it doesn't provide the best results. So by locking it at 4th axis to give us our positioning across this condyle surface, and then doing simultaneous axis movements across these condyles, coming up, coming back, and taking each cut, we get this beautiful, shiny, smooth surface that you need for this implant. So as we rotate the part along the C-axis, you can see that we've got the full condyle surface, the outside swarf, all these fillets. We're able to machine the box area inside here, which needs a very high surface finish because this actually gets polished by hand. And then for this particular knee implant, we have a bridge, and we're able to machine this whole bridge all the way around and all these side walls here. With this particular part, this is actually one of the most difficult knee implants to machine because of that bridge criteria. So we're going to break down the tooling we use to have success with this project. So of course, all of this tooling was provided by Mikron Tool, and I want to explain what each one does before we get into it. So right now we're using a 5-flute coolant through the shank, bull nose end mill to basically come around and finish this outside surface and clean off all that extra casting. So we do a nice 5-axis move all the way around. The surface finish over here and the quality of this isn't incredibly critical, but it still needs to be cleaned up to get a finished shape. What really matters are these next 2 tools. So we actually used a 5-flute ball nose end mill, 8 millimeters, to rough and finish this entire condyle surface. And the key to cutting this material is you never dwell. You never stop, full feed. You don't want any kind of prolonged contact in one spot. because this material is so abrasive that it's going to strip the coating off your tool. So we took it at about a 10-degree lead angle, came across the part, went past the part surface, came up and repositioned. Because if we were to rotate while still in contact with the ball, we would strip this tool out and it would just fail. There's nothing we can do about that with this hard abrasive material. So you really want to get in the cut as fast as you can get it, all the way off, back around, reposition, and continue. And that's how you're going to get this beautiful finish, and you're actually going to get a nice prolonged tool life out of this. You want that heat. You want to push the tool hard. That's going to give you the best results. We actually have several options available through Mikron with this. We had very good luck with this straight shanked 5-flute, but they also offer some reinforced shanks and an 8-flute tool as well for this size. But what we found related to the machine and our tool holders is that the KERN and the power grip holders are very rigid, and we actually had good success with the less rigid, non-reinforced carbide shank. That gave us a little bit more micro deflection kind of in the background and gave us a nice shiny perfect finish and longer tool life. So there's sometimes benefits to having that flexibility, and that's something that Mikron truly understands, which as someone who's trying to put all this together, I really appreciate. Now, the last tool we used is a 6mm shanked taper tool. So it's a 20-degree taper that comes to a 3mm ball. And this tool is what allowed us to get in and do the inside of this box feature. All the fillets you see around the part, the front of this bridge, and then all these side walls. It gives us the length, but also the rigidity with the taper and this reduced shank to get in here, but not be hanging out of our power grip holder so much where, you know, we're getting too much flexion. These surfaces inside this box are really important because they do typically get polished by hand. The outside is usually pretty easy to post-process. You know, you polish it out this way, but the insides, you don't want to have to spend too much time here because it's expensive and it's difficult. But with the Mikron tooling, we exceeded the surface finishes that we needed. And quite frankly, these parts look great and it was a lot of fun to make. I gotta have an excuse to show off this 210 tool changer that the KERN has on the side and take a little bit closer look at the power grip tool holders that we're using for this demo. I just had to show this off because this is like one of my favorite parts of the entire machine. This is our tools right here, so you can see each tool we talked about, the bull nose, ball nose, and taper mill. We're using REGO-FIX power grip PG25. The KERN MicroHD is using HSK 40E holders. This is a 90. This is a PG15 80. And then for the taper tool, because the fixture's at 90 degrees, we needed that longer reach to get to the bottom of that box feature and get around the bridge. So we're actually using a 120mm length holder here. But the different sizes and different lengths kind of gave us the flexibility we needed to hit all the sides of this part where we didn't quite have as much travel as maybe we would have on another machine. So it allowed us to use the fixture where maybe if we were only doing this on the KERN, we would have done a more vertical fixture. So the coolant we're using in this demo is actually Blazocut BC20SW from Blazer Swiss Lube. And that's actually designed for cast iron, steel, aluminum alloys, that type of stuff. In production, in the real world, we would be using something that's better suited for medical applications. You're gonna get better tool life, you're gonna get better heat distribution, less foaming, better cutting performances, and better surface finishes all around. It's just gonna be a much better experience in the production world. Something like a SkyCut, a Synergy, whatever you need. And those guys can really help you find what coolant they offer fits your medical requirements. So this part was programmed in Hypermill. And I got to give a huge shout out to the whole support team over there, because I struggled with a few things and they were on it. They gave me all the support I could ask for, and I really, really appreciate that. I really like using Hypermill for these complex 5-axis parts because their surfacing criteria works really well. There's a million different ways to account for collisions. They use a 1-to-1 machine simulator that gives me accurate cycle times, real collision detections. They create a safe shell around the part. It ultimately just makes me feel very safe and very confident when I throw this part onto the machine. What I really enjoy is the flexibility that their software gives me. And again, I can't thank them enough for all the help they provided me with these projects. I also wanted to point out Bloom Novatest. They are responsible for the laser and probe that we use in this machine. And all these tools were, of course, set off with the 2 Mikron laser. Love it. It's amazing. The probed in our fixture. But what you can also do is use the Bloom probe in combination with Hypermill's best fit module, and it will probe the casting. And if that casting has some discrepancy or is off in X or Y or Z, or maybe spatially a little bit, it'll probe, adjust your program for that offset, and you'll have a perfect part every time. So that kind of allows for some synergy between Bloom and the Hypermill software. So to kind of wrap this all up and kind of put a close to the femoral knee implant out of CoCrMo, we've covered all the technology that we've used to find success with this project, and I've mentioned a lot of things that maybe we could do better next time, or that you could do better on your shop floor. And so I just want to give a special shout out, a special thank you to all of our partners, to everyone who's been involved with this project. I greatly enjoyed hosting the Mikron Medical Day, and I'm really looking forward to next year. So if you guys have any questions, reach out in the comments and we'll provide all the answers we can. Thank you.